video, we're going to discuss direct variation. There's a couple of definitions that you need to know as we begin. The first one is, what is direct variation? Well, direct variation is a linear function, and linear just means it forms a line, that can be expressed in the form y equals kx, where k is not equal to 0. For example, y equals 4x. That would be an example of direct variation. The other thing you need to know is the constant of variation. The constant of variation is a non-zero constant, which we use represented by k, and in the function y equals kx. So in this function, k represents our constant. K always represents our constant, and k is what we often solve for. So for example, in the function y equals 4x, our constant was 4, which means that no matter what we do to y or x, the 4 is always going to be there. So, for example, in y equals kx, y is a function of x. That's what we would say. So, as we do something to x, y is going to change. X would be our independent variable, and x is dependent upon what happens, or x is our independent variable, and y is dependent upon what happens to x. So, as x increases, so does y. To know if an equation represents direct variation, you solve for y. If it's going to equal y equals kx, then it's direct variation. So let's look at this. And we know how to solve for y. This is where you transform equations. So if we started with this, remember we want to solve for y, so we have to peel away all the layers. So in this one, we would first start by subtracting 5x from both sides. So we could say 2y equals negative 5x. We still haven't solved completely for y because this 2 is over here. So we're going to divide both sides by 2. So now we have y equals negative 5 halves x. Okay, so now this does represent y equals kx. So we can say that yes, this is direct variation. And we can say that our k equals negative 5 halves. Okay, so again, to tell if something is direct variation, you want to solve for y, and then you can tell what the k is. Okay, so what about this other one? Again, solve for y. So we're going to subtract 4x from both sides. Okay, not quite done. We're going to divide everything by 3. So right now we have y equals 8/3 minus 4/3 x. Well, since we have this 8/3, this is not in the form of y equals kx. So this one, no. It's not direct variation. For it to be direct variation, it must be in this y equals kx. No plus or minus of anything in front of it. Okay, so let's write a direct variation given the points. So to do this, we know that this represents a y and this represents an x. So we just need to solve for k. So we could say that negative 3 equals 4x. So if we want to solve for k, equals k times 4, or 4k. So to solve for k, we're going to divide both sides by 4. So that means that k equals negative 3/4. Okay, so we found our k value. So now to write a direct variation, we would say that y equals negative 3/4 x. That's our direct variation. What about this one? I'm going to plug in negative 6 for y, negative 3 for x, times k. I'm going to divide both sides by negative 3. I find out that k equals 2. So now, to write my direct variation, I'm going to say that y equals 2x. So this means that no matter what I do to y or x, the 2 will always be there. So this is my direct variation with given points negative 3 and negative 6. Let's do one more. Plug in 1 and 2k. Divide both sides by 2. So k will equal 1/2. So my direct variation will be 1/2 x. Okay. And those are some examples of direct variation and how to find k, which is your constant. And we'll work some more with this in class tomorrow.